Hello, friend. I tell you about validation and verification of analytical methods. Analytical methods are used to produce analytical data in various fields, and the resulting data is used as a basis for making decisions. The resulting data will be valid if the analytical method used has been validated and is in accordance with its intended purpose. Validation is a process, analysis experiment, to prove that the performance of the method meets predetermined requirements. Verification is a process, laboratory experiment, to prove that the standard method can work well and is appropriate before the method is used to carry out testing. Analytical method development is the process of selecting an accurate assay procedure to determine the composition of a formulation. It is the process of proving that an analytical method is acceptable for use in laboratory to measure the concentration of a drug moiety. Analysis method, the start from development, optimization, validation, compendial method, verification, and testing laboratory. For example, non-standard methods in scientific journals. Validation by comparing with standard official methods. 1. Official institutions. 2. Widely applicable. 3. Compendial pharmacopoeial methods. 4th ISO, AOAC, USP. If the comparison results are the same, insignificant differences. It is declared verified and the standard method can be adopted in a testing laboratory as a reference. Analytical method, validation approach. 1. Zero-blind spiking method. 2. Single-blind spiking method. 3. Double-blind spiking method. 4. Standard reference material. SRM. 5. Collaborative approach between laboratories. 6th approach, by comparing new methods with existing methods or standard methods. Validation performance characteristics is 1. Precision 2. Accuracy 3. Detection limit 4. Quantification limit 5. Specificity 6. Linearity and range 7. Ruggedness 8. Robustness. Accuracy 1. Precision accuracy 2. Using standard reference material 3. Spiking against placebo 4. Using the standard addition method 5. It is recommended to use 3 types of concentrations, each with 3 replicates 6. Requirement for assay. If 98 to 102% is validation. Recovery if greater than 80% is good. If reasonable, if 650%. Questionable if 50%. Precision. 1. Repeatability. Same conditions over a short time interval, conducted on the same day with the same equipment and conditions. 2. Within laboratory precision variations conducted on different days, analyses and instruments, but within the same laboratory. 3. Between laboratory precision, different analyses and instruments from different laboratories. Limit of detection, LOD, is the lowest concentration of an analyte in a sample that can still be detected. Does not require validation. LOD calculation with a signal-to-noise ratio of 3 to 1 limit, OGF quantification, LOQ, is the lowest concentration of an analyte in a sample that can be determined with acceptable precision and accuracy under the operational conditions of the method used. Quantified with a valid value. LOQ calculation with a signal-to-noise ratio of 10 to 1. Selectivity, specificity. Selective, able to differentiate between analyte compounds and derivatives, degradants, metabolites, or other disturbing compounds. Specific, able to identify responses for single analytes, pure analytes. The selectivity and specificity test can also use the standard addition method, and then the results are observed. If the sample is added with the standard addition, the analyte should either appear or not. If an addition is made, it means the placebo effect becomes stronger. Specificity, analytical purity test. 1. Using a diode array detector. 2. Spiking technique. Spiking result peak. SACH shows a single peak node and has the same TRRF3. In TLC, different developing systems are used. 4th, GCMS, 5th, LCMS, LCMS/MS. Linearity. Linearity. The ability of a method to show a direct or proportional relationship between the detector response and changes in analyte concentration. This has often been done to observe linearity, where the x-axis is concentration and the y-axis is the instrument's response. If, for example, using UV-Vis spectrophotometry, the instrument response would be absorbance. Then we see if the concentration is increased, how much absorbance, what the response is, linear or not. Well, in this picture, it can be seen that there are several points that deviate from the linear line, which means there are some substance concentrations that do not match what they should be. Then, a linear regression equation can be used to determine the correlation, coefficient, or the value of R. That's all the material we've conveyed is likely to be useful. Thank you for watching. See you in the next video.